Hey everyone, welcome again to the YouTube channel, and here we are again with a new series of segment routing, traffic engineering videos, and this time we will talk about segment routing, traffic engineering with explicit paths. Okay, so this is a video we will explain here, and actually we will use the same network as we used in the previous video. What does explicit path? You know, in the last video we saw that segment routing TE or SRTE has different ways that you can configure the policies, right? It has a way that you can do it in the automated manner. So this is where we saw ODN, and we saw the benefit as well of ODN, right? So you can create policies very easily, automatically. The configuration is really not that big. You don't need to specify the name of the policy, it's auto-created. You don't need to specify the endpoint as well. So those are the things that ODN has as an advantage. The problem, or let's say not problem, but disadvantage of ODN is that you cannot specify explicit paths, right? ODN calculate the paths for the prefixes based on the next hop that is received in the VGP updates, right? So for example, in this case, as we saw also in the previous video, so better go and watch it. So when C2 was sending the prefix to P1, the prefix 200/32, P1 actually reflects and redistributes the prefix from the VRF, because here we saw that there is a VRF here, VRF, and actually this is the same network we were using before, right? So you have P1, P2, you have a RAR vector in the middle, customer H1, customer H2, you have a VRF in both sides, and then here I'm running BGP, here also I'm running BGP. So P2 basically received the prefix from C2, that is a 200/32. Then P2 redistribute into multi-protocol BGP, and it colored the prefix with the number 100, right? So then the RAR reflector received that prefix with that specific color, and then it forwards to P1, and P1 receive at the end the prefix 200/32 with the color 100. This match the ODN configuration with the color, and then the policy basically is created automatically, and P1 finds the path to P2 based on the constraints that we will configure there. Can be metric, for example, can be lowest IGP metric, can be lower path latency, right? Or lower or lowest T metric. We explain a bit more, and we do a lab for ODN in the previous video, so you can go and watch it. But these are the main advantage of ODN, that you can calculate the path automatically, right? You don't need to specify the SR policy name. You don't need to specify the endpoint as well. So P1 doesn't need to explicitly configure the destination of P2 as an endpoint for defining the SRT policy. As I said, the disadvantage is that we cannot say P1, hey, if you want to reach P2, go explicitly here and then go here. We cannot do that, right? With ODN. So there is no way that we can configure explicit paths there. So then the other way that we can configure SRT policies is manual way, right? In manual way, we can configure a part of using these same constraints as ODN, lower IGP metric, lower latency, lower T metric. We can also configure explicit paths, right? So we can actually tell P1, hey, if you want to reach P2, go to P1, provider 1, and then go to provider H2, right? So we can tell actually P1 how he should send the packets for forwarding the traffic to P2. And actually this is very interesting, because we can tell from different ways. We can tell based on IP addressing or based on labels. What does it mean? It means that, for example, whenever I create a policy in P1, when I create, for example, segment routing, traffic engineering, I configure the policy name, for example, P1 to P2, right? When I create this policy, then, for example, for the color 100, I specify the endpoint of P2 as an endpoint. And whenever I put here the constraint that I want to explicitly send the traffic from P1 to P2, I can specify in that policy, right? I can tell P1, hey, you should follow these instructions. You should go first to P1, provider H1, and later to PE2, right? So you should go through the path that is upper. So I can tell, okay, so P1, provider 1, has the, in my case, for example, I have the loopback 11, 11, 11. So I can specify, hey, go to 11, 11, 11 first, then go to 2/32 later, right? So we can give those instructions to P1 in the based on IP addressing. Also, we can give the instructions based on labels, right? What does it mean? It means that instead of me specifying the IP addressing in P1, I can tell P1, hey, go through P1, for example, let's say 16.0.11, let's say the prefix it. Let's say that this is the prefix it of P1, and then go to PE2. That in our case, the prefix it is 16.0.02, right? Just for your information, this lab, we have P1, loopback 0.2.2.2, the prefix it in segment routing, because here we have segment routing configured together with ISIS. So prefix it in the segment routing domain for P2 is 16.2, and in P1 is 16.0.0.1. I don't have prefix it in P1 and provider 1 and provider 2. I don't have any prefix it. Same as the raw reflector. So raw reflector actually even it doesn't have segment routing. So I can give to P1, hey, go first to provider 1 and then to P2 based on the labels. And this label here also can be the adjacency seed, right? It doesn't necessarily need to be the prefix it. So for example, I can refer to provider 1, like is this guy here, based on his adjacency seed of this interface, for example, right? I will probably do a YouTube video based on explaining about the two types of labelings in segment routing. So if you are new in segment routing, probably you're wondering what is adjacency seed, what is prefix seed. So segment routing has two labels. Prefix seed is basically for loopbacks and is the mostly used for the services in segment routing, encapsulation of the services. And then we have the adjacency seeds that is basically for all the point-to-point interfaces. I will do a YouTube video explaining about those two types of labels, so don't worry for now. Just bear in mind that we can configure these two types of explicit paths in P1 in the manual way, right? Based on the IP addressing or based on the labels, right? In my case, in this video, we will do based on labels. So, and there is another way that we can configure SRT policies is PCE. I have some videos around PCE, how it works and what things you need to consider. So please go and watch it if you want to learn a bit more about it. So first, the previous YouTube video in English we did, we look into ODN. So I have configured again, and I've written this very many times. We were doing a lab in ODN. This time, in this video, we will see configuring explicit paths based on labels, okay? So this is a bit of the overview why we might need explicit paths. Just if you wanna, if for example, we have some services that once we want to direct into some specific path around the network explicitly without relying on some intelligence or calculations in the box like ODN does, then we can configure explicitly, right? So in this lab, as I was saying, we have ISIS, segment routing configured. This is P2. The prefix seed of P2 is 6002. The prefix seed of P1 is 6001. This is a raw reflector. Here I have BPN before, an address family BPN before. Here I have an address family BPN before as well. Here I have a BRF as well. C1 and C2 are the customer age. C1 has a loopback 0 that is 100/32, and C2 has a loopback 0 which is 200/32, right? So they both are running BGP between the PE to CE protocol, right? So basically, P2 is actually receiving the prefix 200 from C2, is redistributing to multi-protocol BGP and coloring that prefix with color 100, right? Then P1 received the prefix 200/32 with the color 100. This is already all configured. I have segment routing enabled around all the network. I have also ISIS enabled with Y metrics. Distributed link states for segment routing configuration is there as well. So all the configuration for segment routing is there. If you want to see what is required, please watch the previous video for ODN. There I explain a bit more what we need for configuring traffic during the network. So for now, we will go through P1 and we will create a policy, a manual policy, creating explicit paths to tell, okay, since P1 is receiving the prefix 200/32 from T2, then in P1 we want to reach P2 through provider 1. So we will direct the traffic for that color 100 for those services only go through provider 1, and then we will go through provider H2. So this is what we will configure in this lab, right? So we will go through P1, configure the explicit paths based on labels, go to provider 1, then go to provider H2, then we create the policy, and we attach that explicit path within the policy for forwarded traffic to those services. So for that, I need to go to provider H1, of course. I need to first configure segment routing traffic engineering, right? First, I need to know what is the label that I can use for represent provider 1, because as I said, I don't have prefix it here. I can represent obviously P2 based on the label 16002, but how I represent provider 1, well, I need to see probably, and what I will do is I will check the adjacency seat of this interface, right? How I can see it? I can check it there based on show ISIS database verbose provider 100. So here I see show ISIS neighbor, show ISIS database verbose provider 100, and here I see this adjacency seat that is 24,013. So then I can use this label for configuring my path through segment routing traffic engineering. So here I can configure the explicit path. So actually you can create segment list. This is a way that I can create the paths that are explicitly in segment routing traffic engineering. So I create a segment list, then I say a name. I put a name there that is P1 to provider 1, then to P2. Then here I should create index values. So index 10, then MPLS. As you can see here, you can specify an address as well, but I will do labels. So label, then here I specify the label 24,013. So what it is actually, this is the adjacency seat again of this specific interface. So this interface here of provider 1, this one here, the gigabit 00, has the IP address 10.1.1.10, sorry. So this is adjacency seat of that interface from the provider 1. So if I specify this actually as a first value to reach, then provider H1 will reach first to provider 1. So then index 10, index 20, then I can specify freely the prefix it, right? So this is what I can do and how I can have my explicit path policy already created. Pretty easy. So bear in mind that if you want to create explicit paths in segment routing traffic engineering, you need to first, the command is actually segment list, and you specify the name, and then index represent the order that it will follow. So index 10, for example, is the first one, 20 is the second one. If I will have index 1, then index 1 will follow first. So it depends on how you want to create your strategy, right? I use index 10 and 20 just for showing up in this video. So then here, the first one that will go is through the VLAN, or sorry, not VLAN, label 24,013. That is actually, again, the adjacency seat of this interface from provider 1, right? And the next one will go to 16.2. So this is the prefix seat of P2. So this is pretty clear. For P1, we will first go to provider 1 and then to provider H2. Perfect. So then what I will do and what I have to do is create a policy, right? So segment routing, traffic engineering, policy, name, I should put a name for the policy, P1 to P2, right? So then here I should, obviously the policy should have a color. So for which type of prefixes this policy will be, color 100 is the one that we are receiving from P2. So I will put color 100, endpoint IPv4 2222. Actually, this means that I will use this policy for the color 100, and the next hop for those prefixes will be the endpoint 2222. That is P2 in my case, right? So here then I need to put candidate paths preference 100, and then here I put explicit path segment list, sorry, explicit segment list, and then the name P1, P2. right? So what I did here, basically, the first step, I created the policies, the explicit path, that is actually the segment list based on the labeling, as I explained it. So I created that first. Then I created a policy that will be used for all the prefixes that have the color 100 or are marked the color with color 100 that have explicitly then the next hop of P2, 2. Then I use candidate path preference. So this candidate path preference probably is new for you. So actually that what it means is that is the preference that I want to give to one specific constraint. For example, I can have preference 100 for this, and in this preference 100 I am attaching the segment list. So it means that this policy will use that explicit segment list. But if I configure a preference higher, then this preference higher will be preferred, right? So the higher preference is preferred. So it means that if I have preference 200, that will use another explicit path. For example, let's say I have the preference 100 that is going in this way, but if I have a preference that is 200 and it will go in this way, then this one will be chosen, right? So the preference basically tells you what path will be preferred, right? In my case, I just have only one, so obviously the policy will use that one. But again, if I will configure a higher preference with another path, then this path will be preferred. So, and then we attach the explicit segment list, right? So this is where we want the path to go. So in this case, it will go through this path, right? I am saying a lot of explicit path and things like that because this is actually how we learn it for MPLS traffic engineering. In segment routing, it's the same thing. Obviously, the naming is segment list, but actually it refers to the same thing. So that's the configuration that we have. So I will commit this. And then I will first make sure that I am receiving the prefix 200, 200, 200 in P1 from P2, and the color is 100 from that prefix. So that's very cool. Then I will just verify that the segment routing traffic engineering policy has been created. So I will take a look here, and then we see that the policy is actually up and running. So here it figured out that this adjacency seed represent this path and this network. That is a link between P1 and provider 1, as you can see. So this link has the 10110/24 network. So it means that the path will go first to the provider 1 through that link, and then it will go to 16.2, that at the end is a P2, right? So again, how we can verify this, show BRF. I think that the BRF is blue, 200, 200, 200, 200. So here we have that, okay, it's in the routing table. Then I will do show Ceph blue, 200, 200, 200, /32. So show Ceph, I guess, blue VPN. Okay, so this is blue VPN, 200, 200, 200, 200, /32. So then here we have exactly the same thing as we see with ODN. So the policy is referred into the Ceph, that is P1 to P2. This is the policy name. What it helps to put in the Ceph and refer this policy into the Ceph is actually the binding seed. That is actually this one here, right? No, sorry, it's this one here. It's actually the same thing. So this label is the binding seed that allows basically the policy name to be referred here. And then obviously whenever there will be a traffic from that specific service, for example, C1 will send the traffic to P1, then P1 will actually hit this Ceph table, and then it refers to the policy P1 to P2 to send the traffic through that specific policy. So I have C1 and C2 here. Let me just take a look if we can do some trace route just to make sure that the traffic is going as we want. So let me just go through C1. Here I will do trace route to 200, 200, 200, source 100, 100, 100, 100, numeric. So then we see now that the path goes through P1, that is this IP, 100.1.1.1, 10.1.1.10, this is provider 1, right? And then we have 10.1.5.10, that this is the link between provider 1 and P2. And at the end we have P2. Sorry, we don't see P2, but we see the ending IP address of C2. So that's all about explicit path using labeling. I hope that this video has been informative for you. And yeah, keep it watching, and then we will release more videos about segment routing traffic engineering. Thanks a lot for watching. See you. Bye.